Okay, so I don't see anybody new on the community call. So we'll skip introductions. If somebody comes in later, we could do that. I have on the agenda, Tyson will lead off, then I'm going to give a brief update on upcoming releases. I'll start release votes. We'll start this week and into next week. And then since there's time, I'll do a little bit of show and tell with the DigitalOcean droplet for Apache OpenWhisk that was announced yesterday as part of the DigitalOcean marketplace launch. So Tyson, you want to just get started?
Yeah, sure. Let me get back in here. So I didn't get as far as I wanted on preparing the PR, so it's not actually on the OpenWhisk pull request yet. But I wanted to go ahead with sharing this information and just give a heads up, and I'll try and get it out there today. But basically, I've been working on a change to the invoker to allow a better integration with clustered resources. So using either Mesos or Kubernetes, for example, to launch action containers. So some background, we're specifically talking about action containers and not the containers running the invoker or the controller. And basically, this is where the invoker is using a container factory that knows how to use the cluster manager, either Kubernetes or Mesos, to launch containers somewhere within the cluster. And the main point of this change is to tolerate a dynamically changing cluster state, so that, for example, if we scale up our cluster so that we can launch 1,000 containers instead of 100 containers, we don't want to reconfigure invokers or restart controllers to have any visibility into that cluster state. So we're also, not considering with this change any changes to dependencies like Kafka or Zookeeper or anything like that. So just to kind of level set about which specific containers we're talking about, just the action containers. So how things work today in the controller with the sharding container pool balancer, there's a few kind of hiccups that we've run into, potentially related to our specific configuration, but they're real nonetheless. So one of them is that there's some assumptions about the distribution of requests across controllers. And what this means is that the resource shard that's allocated to a controller is based on the number of controllers and the configuration of the invokers. And there's some assumption here that the launching of containers will be kind of evenly distributed across the controllers. And we have a few cases that have come up where suddenly in certain types of loads, we end up, flooding one controller a little bit more than the other or a lot more than the others. And in those cases, we see things kind of go off the rails because they only have visibility into resources that are organized into their own shard, and they get this feeling of being, starved, and now, that controller behaves like it's out of resources, whereas the other controllers are fine. So, that's not great. I don't know if other folks run into that, but it's part of this kind of set of changes. So the other thing is that if you look into what goes on in the sharding container pool balancer, is we have a lot of resource scheduling going on based on the notion that each invoker has a certain pool of memory to allocate to containers. And so there's a lot of accounting that goes into tracking which invoker is launching which containers and how much memory they take. really we want to do that in one place and not in multiple places. So the risks, that we've seen is dealing with not even round robin distribution, and the resource scheduling being unaffected by cluster changes. And really, what we want is that for the controller to not care about the invoker configuration state, and really the the controller only should care about whether the invoker thinks it will be likely to be able to launch a container. And right now, we already have sort of a facility for that in the terms of the health check, where the controller sees each invoker as either healthy offline or unresponsive, or I think there's an unhealthy one also. But in general, like if we look at it between like normal steady state being, it's either healthy or it's unresponsive. If it's overloaded, it becomes unresponsive. So the summary of what I'm proposing is at the invoker, the basic requirement here is to not ever over provision. And so what this means is that, once the cluster reaches capacity, according to the cluster manager, we need to do the right thing in terms of stopping containers versus trying to arbitrarily wait for some ability to launch containers. So there needs to be some way to signal from the cluster manager that the invoker can or cannot launch a container of whatever particular size. So in order to do that, we can collect stats on the nodes that are launching action containers so that we can determine some launchability. And this will be an estimate, but in general, we can get pretty close to, detecting whether the scheduler is going to be able to launch this container or not. We need to track reservations because there's going to be delays between when you ask a cluster manager to launch a container and when it's actually scheduled and reflected in the stats on the nodes where the container is actually launched. So this is something that the cluster managers will do internally, but we can do the same thing so that we can make decisions quickly inside the container pool about whether we can launch a container. And pre-warms, there's another kind of side note here, which is, right now you can always launch more pre-warms, and really this needs to be driven by resource availability also, which is if we take a pre-warm, we can't assume that we can launch another one. That pre-warms are also going to be subject to whether the cluster manager is going to allow us to launch any containers. And then at the controller, there's no changes, but we're going to rely on the user memory for the container pool configuration set to some large number, so that basically every invoker at the controller is viewed as having limitless resources. And this has some caveats with how the load balancer works, but for now it makes it so that we can avoid making lots of changes controller to take advantage of this.
Tyson, quick question.
Yep.
On the previous slide where it said favor stopping idle containers and waiting for resources, the first sub-bullet, doesn't that happen today? When the invoker needs resources, it just kills off anything that's idle?
Yeah, it does, but the point at which we enter that state is not based on the cluster state. It's based on this static configuration and the state of the container pool.
I see.
So yes, it does do that today. And the change there is that entering that state of determining that the container factory is at capacity moves away from this static configuration of user memory, container pool user memory, and becomes something more dynamic based on the stats that are collected from the cluster manager.
Okay, thank you for your clarification.
Yep. So just to kind of diagram at a high level what these changes are. So the basic change is in the run message handler in the container pool. And so, first of all, we want to do, we only want to change things for things that are behaving in a clustered managed container factory. I can't get my mouse to show up in presenter mode here in Keynote, but if you go through the first step of run, we check, is it cluster managed? And if it is, then we do the usual warm and pre-warm check to see if we can use an existing running container. And if we still need a container, then we check to see if the cluster has space. And this is kind of the first big change. And the changes here is that it's based on data collected from what I'm calling node stats, which is basically within the cluster, each node that launches Action Container is going to have some stats that are available to the container pool. And I'll go over collecting those in a minute. But this will tell us kind of whether some node in that cluster has the ability to fit an Action Container of this size. And then we also need to pay attention to reservations, which are basically tracking state of things that are in flight but not yet considered in the stats. And so when we launch a container from the container pool, container proxy, there's going to be some delay, potentially a long delay, between the time that the container pool says that it was launched and the time that the cluster resources are allocated and the container started, and the stats that are available for allocating are updated to reflect that. And so I've kind of separated these out into two data sets that are tracked in the container pool. And so once we determine whether there is space within the cluster, if yes, there's space, then we go ahead and make a reservation and we initiate the container creation process. If there's no space in the cluster, then we go through with the similar removing idle resources and then creating new resources. And one note here is that when we're removing resources, we make a similar reservation, but it's a negative reservation. So we're freeing up resources, but they're not yet actually allocatable. So reservations can either be positive, where we're starting a container, or negative if we're stopping a container. So once we go through the removal process, then we can proceed, if that was successful, if we had removable containers that in theory should fit the resource needs of the new container, then we'll proceed with making a reservation. So it's similar to what happens today, except for a few very important details, which are whether or not we think the container factory can launch a container, and tracking reservations and stats on nodes to do fit analysis on whether we should be able to launch a container of that size. So the other workflows are how do we track these things? And so from the node stats point of view, the way I have it set up currently is that the node stats data is coming from the ACA system event stream, and really this can be updated from anywhere, but the kind of obvious choice would be to say a container factory implementation would emit these data points to the event stream using whatever mechanism for collection at once. But it's basically a decoupling point to separate out the generation of these node stats data from the container pool and keeping the container factory from getting too mixed up in everything that the container pool is doing. We have in our example, we have a Mesos container factory change that would be coming on top of this that would say, okay, now the Mesos container factory is going to generate node stats data, and hopefully it will be obvious how someone can make the same kind of change to the Kubernetes container factory to say Kubernetes is going to collect data from kubectl or from the metrics API or whatever, and generate the same type of node stats data so that the container pool can access it and make decisions based on that. And then the other change is at the container proxy layer, where we need to pay a little bit more attention to the start and stop complete process within the container lifecycle, so that we can update reservations to say, okay, the container was launched at the container pool, and the container proxy has propagated that into the container factory, and now the container is actually launched, and so the reservation needs to be updated to say, okay, this reservation is actually now complete, versus you having having some resources that have been allocated but not actually used yet. So just some details about the implementation, and again, I apologize for not having the PR ready, but I will get it out there today as soon as possible. The node stats. I know this will be a question: is this a Mesos thing? And the answer is no. But there is a resemblance to Mesos offers workflow. This is a little bit how Mesos works, but there's definitely some differences there. And actions need contiguous resources. So the point I want to make about, well, can we look at the cluster stats in aggregate to determine these things? And the answer is not really, because really we have to know whether a specific host can tolerate a contiguous set of resource allocation. So 100 megabytes available on a single node is more usable than 1 megabyte on 100 nodes. And so we really cannot look at the aggregate state of the cluster to determine the ability to schedule these things. Container factory implementations can use any means to collect data and emit to container pool via node stats update events. So this is what I was getting at, is that Kubernetes can use describe node or the metrics API or some other thing that I don't know about in Kubernetes to emit this same data. Mesos can use offer data or the Mesos leader API, or potentially some other mechanism. Yarn, same thing, assuming there's some way to collect data to reflect the state of the cluster in a way that indicates per host what is available resource-wise, then there can be an implementation for that container factory. And container pool will cache node stats for reference, because we really don't want to introduce delays into the container pool that says, okay, for every run message, we're going to reach out to the container factory or whatever and say, can the cluster manager launch this action? Okay, yes or no. And then the next run message, we don't want to tolerate delays in the run message processing at the container pool. So we have to deal with the node stats on a cache basis, and we can allow that by emitting node stats periodically from the container factory and tracking reserved but not completely allocated within the reservations data that's cached in the container pool also. And then just some details on the reservations. Is this a meso saying no? And this is strictly for the times between when the container pool performs the resource allocation within its own logic and the actual resource allocation that happens within the cluster manager, and it accommodates for delays in updates to the node stats, so that we can be somewhat accurate when we're when the container pool is making these decisions. And so really the goal here is to prevent over provisioning when we have a burst load, where the real risk, which I'll get into, is over provisioning in the cluster managed case is a little bit more problematic, because you don't get a fast failure in the case where it can't launch the container. You probably get some delay, potentially a long delay, between the time that you try to launch a container and the time that the cluster manager actually gets back to you to say, oh, we tried for a long time and we still can't launch this container. And so really we need to avoid this case of over provisioning as much as possible. And other risks, the controller only stops using the home invoker when that invoker becomes unresponsive. So the kind of question there is, like, when does the invoker actually become unresponsive? So one case is when the cluster reaches capacity and doesn't do the right thing. And the other case where it becomes unresponsive is more of just a process heap starvation, where if it's launching hundreds or thousands of containers at one invoker, the initialization of containers, depending on the size of the action and all this, can really affect the heap. And so being able to increase the responsiveness of the invoker state going from healthy to unresponsive will be another kind of optimization that needs to be made to make this work better. But for now, the big change there is that instead of doing accounting at the controller now to track which invoker should be used, it would strictly be based on whether it's healthy or unresponsive. And another optimization that I mentioned here is to improve controller tracking data to be based on activation weight, and instead of only being based on being unresponsive. And what this means is that there's other forces at work that will make the invoker usable or not, and really directly related to the size of the action, but they're more related to the size of the activation, meaning the request size and the response size, and the effects of initting an action container on the effects of that on the invoker heap. So one other note on over provisioning is to add some buffer amount so that we allow for container pool to think it's becoming over provisioned, but still have some buffer in the actual cluster managed view of resources, so that we don't have to consider that the container pool has a high level of accuracy with the cluster, but it should have up to a certain buffer amount, some level of accuracy. So that would allow some flexibility in the data being super accurate all the time for determining launchability. And controller, like I said, sharding between invokers would not be really used in the same way. For now, strictly just being based on unresponsive state, as opposed to the size of the action containers. And another alternative is to provide the alternate sharding implementation. I think there's a lot of possibilities for what can be done there, but I'm kind of ignoring that optimization for now. And one of the things that we've seen that makes this a concern is that container init using a substantial amount of memory compared to the size of the action code when a init is being processed. So if we have a action that is a zip file that's 10 or 20 megs, it takes hundreds of megs of invoker heap to go through the initialization process. So I think there's some other kind of optimization that maybe we can look at in the invoker. It's not clear what exactly that would look like, but something to change how the init protocol works.
So that's interesting on the init side. I guess I'll start there since that's where you ended. Has there been any profiling to see where that bloat is coming from?
No.
Okay. Yeah, I would have thought. I mean, the action code does get held in the invoker memory while initialization is happening. I didn't expect that kind of bloat, so it's interesting you mentioned that. I mean, it sounds in general that this is a good direction and an improvement overall because it's making the state of the invoker less heuristic driven and more faithful to the actual underlying resources of the machines that you're running on. For Kubernetes, I wonder if something like Istio comes into play. I don't know, maybe others can comment on that. And then a third thought on this is, there have been a couple of documents on the wiki about changing the way the controller does its load balancing and different approaches to sharding. Do you have any thoughts on how those would relate here? You said there's no sharding really with this new proposal, or the way this would end up working, at least for Mesos. Do you know the proposals I'm thinking about, and do you have any comment on that?
I'm not sure which proposals you're thinking about. The one that I can think of is the talk about the overflow buffer, where we avoid queuing to Kafka unless there's a case of overflow handling where resources are not available according to something at the moment that the activation arrives. Was there?
That's one of them. Another one I'm thinking of is Dominic Kim's proposal of basically routing actions as Kafka topics, and they go to different invokers. And then there was something from Marcus. I think he called it vertical sharding. I don't remember exactly the details of that one though.
Yeah, I guess the routing of actions as Kafka topics, I think, we've expressed some concern about the volume of topics being unrealistically manageable. And so, we haven't really looked at that as a viable approach. I don't know if other folks have or not. And I'm not sure about Marcus's other proposal.
Right. Okay. Those are questions for me. I'll when the PR is open, I'll look forward to going through that code. I'm sure there'll be more questions then.
Yep.
Any other questions or clarifications from the participants on the call?
I just want to say this looks really great. So thanks for doing this, Tyson. I'm looking forward to the PR. Yep. It looks like it'll be a great fit for Kubernetes. I guess we talk about the PR. So in Mesos, do you log directly to the platform logging capability? Because that's one of the things that usually gets the invoker pretty bogged down, is dealing with logging. So
no, well, in our case, we don't do any log collection in the invoker. We use a a separate process for collecting container logs. Yeah.
Okay, yeah, that makes sense. I mean, that's a key. If the invoker is going to be handling a fair amount of load, the key, we can't have it handling the logs too, because that kills it.
Yeah.
Sorry, go ahead, Tyson.
I was just going to say, I haven't spent a lot of time driving adoption of not doing log collection in the invoker, because we have a way to work around it for now. But that's something that I would encourage everybody running Kubernetes and Mesos to not do, is to collect logs in the invoker.
Dave, you had done some work on maybe aligning the log collection a bit better with Kubernetes, perhaps. I saw recently you closed those PRs. Is that still a thread of work that you or others plan to pursue, or do you know?
I mean, I think the particular thing I was doing, I think doesn't really work very well. There are ways you can lose logs that are not attractive, and you can't trust the user container to tell you what namespace it belongs to accurately, so that doesn't actually work. I think we probably ought to be moving towards more of the structured logging support that Tyson was advocating for, 6 months ago or more. Is it, the runtime is just auto do structured logging, and if you don't do structured logging, then your logs go to dev null.
Yep.
One question I have is, are folks using the Kubernetes Container Factory to launch action containers? Are you guys using that, or it wasn't clear if anybody's actually using that?
So is that a production question or a sort of playing around question?
Well, I guess both. Like, definitely, are you using it in production? And secondly, is anybody like experimenting with it at all?
Right. So I use it around for development. The IBM Cloud Functions is not using the Kubernetes Container Factory in production, and I think is unlikely to.
Okay. That was kind of another question. Is like, is there any intention to use it? But yeah. Okay.
I guess, Dave, you can't say what it's using then.
I'll let Carlos handle that.
Carlos dropped off the call.
Okay.
Oh no, he's still there.
He's still there.
Okay, fair enough. Anything else on this topic?
I think, Roderick, I wouldn't want to lose what you said about Istio, and I think it's an interesting design pattern. If we offload, like if we can separate the control plane, which is handling the starting and stopping of containers, if we can quickly tell Istio where those containers are and write some plugins for Istio to do the authorization, I think we can offload the data plane to Istio.
I think that's a conceptually interesting idea. I've been lurking a little bit on the Istio can operate at the scale that we need with any kind of performance.
Is that mainly driven by the fact that it's very slow to tell all the Istio nodes where all the containers are?
It's slow, and I've had some side conversations with some people at IBM who work on Istio. They have some quadratic algorithms in there. It's not even, it's not even that they have some linear algorithms. They've got some algorithms that are super linear for keeping track of all the network connections and all the things. So I just don't see it realistically scaling. That's got my HPC hat on, or anything that's not logarithmic is a disaster. Like linear is bad. So, and they're super linear.
Yeah, I guess there's probably some interesting angles here between the Knative serving front and some of these discussions. Will be interesting to see the relationships.
Right. I mean, I think it's completely practical for small clusters, but beyond that, I think it has trouble. I mean, it might eventually get fixed, but right now it's certainly not scalable.
Interesting. So yeah, I guess my question was if it's a design problem that Easter has changed the design, that's difficult. But if it's an implementation thing that we could possibly at some point contribute, that would be an interesting thing because there's a lot of contributors on Istio.
All right, I'm going to call this topic then and get back to next thing. So I took, in the last couple of weeks, I've been working with Dave and Carlos a little bit to get us ready for some release votes. And I wanted to just give an update on that. And as part of that, I had a chance to go through a lot of the pull requests and issues that are open. So some of you suffered through those notifications if you watched the repositories. I wanted to call out some pull requests and new features that are coming. And then if there's time, I'll talk a little bit about this DigitalOcean one-click deployment for OpenWhisk that was announced yesterday. So PR, I'll start with PRs of note. So there's one PR that's open that I think is ready, although I saw a comment earlier today on the issue I have to address potentially. This PR, James Thomas last week also mentioned, removes the API key from the actions environment by default. And so if you have actions that need to invoke other actions, you need the OpenWhisk API key for that. And where today we provide that key on every invocation, it will now become an explicit opt-in on newly created actions for mitigating backwards compatibility for deployments that have essentially actions in production already. Existing behavior is preserved. So if actions that are in the database already will continue to receive the API key, absent the annotation that's required otherwise. But if somebody has a pattern of say, tearing down all their production actions and then deploying them anew, they should be aware of this. The comment that was on the issue was whether there should be a deployment time flag to potentially allow others opportunity to better inform their users and adapt. Otherwise, the PR, I think, is code ready and hasn't received any new input in more than 2 weeks. I merged last week a PR from that added support for running OpenWhisk on top of a yarn. I thought this was really neat and sort of takes the OpenWhisk abstraction of having this arbitrary container factory and then just delegates all of the resource management to yarn. I saw Sam showed me a demo. He might have done it at one of these reviews. I can't remember. And I thought it was quite neat. And I think he's coming out with a blog sometime this week or next week on this. So that's interesting. I think, as Tyson said, this model that he was proposing earlier probably can benefit in this space as well. There's new PR that's now ready for review for doing multi-region support. So if you're deploying OpenWhisk and you have databases spread out across regions, there's some issues with cache invalidation. So Chetan has a PR that sort of implements a better cache invalidation strategy. Chetan, do you want to say anything about that?
Yeah, so this PR is for now specific to Cosmos DB based deployments because that's where we get an easy multi-region deployment and you can have multiple clusters connect to the same Cosmos DB in different regions. Once the pattern is validated, probably we can extend it to other database which support that kind of feature.
Yep, great, thanks. There is a PR which I went through, and it looks like others went through as well, for adding this Karate BDD-driven tests to OpenWhisk. I don't know what's next on that PR. I had some reservations about introducing the testing framework, but there's some compelling arguments for having it. And it looks like, Tyson, maybe you might have a better perspective on this. This sat for a while and then had to be rebased and conflicts resolved. So I think we need just a clear direction on, are we accepting this contribution? If so, then we should just accept it before and start running the tests as part of Travis so they don't rot again. Or do we want to close the PR? I don't think we should just let it linger. further. It's already been open quite a while, and I think it deserves, a decision one way or the other. So if you're not familiar with this PR, I provide the link there. Take a look at it. If you do want to make a comment now, I'll pause for a brief moment.
I will try to light a fire under some folks that may have more concern one way or the other, and get some direction, at least from Adobe's side, on that. Okay, great. I just don't think it's fair for the contributor to, and I apologize, I don't remember the name off the top of my head, to sort of just leave that hanging and have them do work. So if either we accept it or we don't. So I appreciate that. Thank you. We do have a new language runtime for enabling Rust support. So thanks to Roberto Diaz and also Michele Chiabara, who did the action loop, and now that fully supports Rust as well. And I think the next step there is adding the action interface conformance tests, and the repo already exists. And once the tests are enabled, then we can start pushing that image from the repo to Docker Hub and include it as part of the OpenWhisk runtimes manifest, so it's more easily available.
I'll be reviewing that because I'm learning. I'm learning Rust. That's another language. But I have some feedback on the ergonomics for the main function API of using hash map versus JSON value. And comparing that to what other serverless platforms are using, like for example Amazon Lambda. So yeah, I'll comment or open issues or in the review, so we have a good base ergonomics for the function signature, which I think might require changes. But so far so good. I was happy. I brought Roberto from Twitter, lured him into Slack, and thank you for Michelle for jumping on board. I know he's very busy on enabling him on doing that. So,
just to add, actually I had difficulties in trying to write the hello action in Rust. I spend a lot of time wrapping, so probably there should be a better way, but we need a Rust expert because I have no idea how that should be done better. So if you can do some GitHub page or something, it would be the best way to add the support for a better way of doing the actions.
Yep.
Great, thank you, Michelle. Okay, so anybody else want to call out a PR or something I didn't note? They want to bring attention to it?
I just wanted to thank you, Roderick, for putting a big push on. It's useful to get a bunch of this stuff cleared out, and I really appreciate it.
Thanks. Yeah, I think our PRs fit on one page now, so it's a good. I find it useful. So part of pushing a lot of these pull requests and making progress there was trying to work towards the next release wave. And we've had discussions about, I think we've called it the Uber release, basically releasing all of the components of OpenWhisk so that you can stand up an entire deployment that not just includes the system components, so the runtimes, the CLI, the feed providers as well, and all of that have a consistent version number and potentially deliver a better experience. So I'm a bit over a week behind on what I wanted to do. I had sent an email to the dev list for discussion about the readiness status for the runtimes and the CLI related repos. There's been no feedback on anything that's holding up sort of doing the release. So I'm hoping to start that wave sometime this week, and it'll surely go into next week, just given the timing in terms of having to orchestrate the votes, et cetera. So the runtimes will happen next. These are kind of leaf nodes, so it's easier to start from the bottom up. And the CLI is another standalone component. Then have to sort of strategize and figure out the next phase to go from there on which components to include. I think this is important for eventually driving us towards graduation as well. So it's important to do. Any comments on release?
just want to say that I was working on the CLI stuff, and I've got one PR that seems to persistently be failing. I updated the dependencies, and now we've got persistent test failures that have failed 3 or 4 times in a row. So I'm going to try to dig into that, but I don't really know very much about the CLI. So
okay. All right. So I'll use a little bit, about 5 minutes, to then sort of talk about the one-click deployment on DigitalOcean. So this came up within the last 2 weeks. There was an opportunity to work with the DigitalOcean Marketplace team to include Apache OpenWhisk. If you're not familiar with DigitalOcean, basically they have this, it's a really nice, slick experience where you can deploy what they call droplets. It's really a virtual machine. Comes up within seconds. They have pre-populated images and allows you to basically just deploy VMs. They've recently added things like database as a service and Kubernetes as a service. And so yesterday they announced their marketplace, which was a way for third parties to provide droplet images. I've provided the link there. You can go to marketplace.digitalocean.com or just Google it and it'll take you there. They have several interesting packages there. This is not an endorsement of DigitalOcean in any way. But they had sort of a functions category for running serverless functions. And so one of the images that's there today, if you look, is actually, I'll show it.
One demo, one live demo.
Yeah, I'm going to do a live demo. So if you go to functions, you see OpenFaz is there. And our image, the Apache OpenWhisk image, had to go by a different name. So for it's called Nimbella Lite. Nimbella is the name of my company, and it talks about OpenWhisk in terms of what it's providing, and you'll see sort of the capabilities that I've bundled in there. I'll talk about that a little bit, and sort of allows you to just one-click deploy this image and get started with an OpenWhisk installation. And it's kind of nice, I think, in terms of the overall provisioning. I did start a discussion about the naming issues. The description that's live on the website today will change. I've submitted a change request just to highlight better the Apache OpenWhisk brand. I was very cognizant of making sure that we were promoting OpenWhisk, to the extent that was possible, and not running afoul of the Apache trademarks, et cetera. So, if you have comments on the issue that's there, please go ahead. So it's not just OpenWhisk in the image. One of the things we did was we took OpenWhisk and then we added to it something that I think makes the onboarding and developer experience a little bit nicer. So using IBM's KUI framework and technology, which some of you have seen in the past, called the shell in various forms, we added essentially a web-based deployment environment. It allows you to sort of interact with your OpenWhisk backend, but from within your browser. I like to think of it as a richer, more powerful UI for developers. And one of the most notable things I think that I like about it is that you can run your Whisk commands directly in your browser. You need to download the CLI, but you can create actions, you can author actions, you can invoke them and do all of the things you'd expect from your CLI, but in your browser. There are some limits, of course, and part of the things that I'd like to improve is how much of that experience can be seamless from your desktop to your browser. KUI and the capabilities we have in the Workbench also allow it to work with the OpenWhisk Composer, so you can actually compose applications that are compositions of functions and deploy them as part of OpenWhisk. We also added some OpenWhisk specific tutorials. So I thought I'd just show a few screenshots of that, but since I have my browser open, maybe I'll just do that live. So this is my droplet. If you want to use it, go ahead. You can mine Bitcoins if you like for $1 a week. So if you go to the image and type /hello, it brings you to this Workbench tutorial. This is using a really nice facility in KUI for building tutorials. Talks about the Workbench. So one of the things we added is the ability to sort of navigate a little bit easier through the experience. it tells you how to get an API key, walks you through creating a new action. Whoops. Live demo, of course. Oh, I need an authentication key, which I don't have. We'll come back to that. How you create your first action, how you use different kinds, how you invoke the action, how you pass parameters, webifying so that you can expose a URL, activation lists, and activation grid, which is, I think, a very interesting way of looking at activations. I'm not going to show all of that, but what I wanted to show was something we call the functions playground. So the playground, as you saw when I just went to the workbench, you need an authentication key to use OpenWhisk. And so we thought in terms of the onboarding experience, it'd be nice to just use it, maybe tire kick, or actually do some development without an authentication key. So we added this playground that allows you to do that. It has low limits on the functions. It currently supports Node.js and Python, but it's intriguing in that you can actually write a function and expose it as an API key. As an API endpoint, you didn't actually need to create an account or talk to an administrator to get a key, et cetera. So this is a screenshot of it. I thought I'd maybe do this live, and that'll be more interesting if it works. So I'm going to close this and type playground. All right, so you get some sample code from within here. I can just run it directly. And it runs, you get stem cell containers, nice experience. And if I click publish here, I get a URL, which I can copy and open in a new link, and there it goes. So as you saw, because I failed earlier, I didn't have an authentication key, you can actually run this and now have an API endpoint. You can create a Python action, same thing, runs, exposes an API endpoint. And we're working on the experience, but you can sort of create actions within here. We sort of arbitrarily said you can create 3 actions in each language. So I think it's a nice way of sort of just doing things without having to really buy into getting a key and figuring out how to use your with CLI, et cetera. I just want to write a function and try it out. So I thought I'd do a more interesting example. So I'm going to paste some code in here, which I wrote earlier. So this does image reduction. This was an example that somebody asked for in our Slack channel some time ago, and I wrote the code. So I've cleaned it up a little bit here. And I can run this immediately from after pasting it, and there it is. It needs a URL. So I'm going to use the image of a cat. Those are always popular. Where is it? So here's the original image. I'm going to just give the URL in here and say run. And so there's the resized image of the cat. Now I can publish this and do the same thing from the browser. And there's the cat. And just to show you that it's real, if I just click on this URL, it doesn't load anything because proper web action should always return a response. So if I say URL equals undefined return body URL, publish again. There you go. So I just sort of think that experience is very low friction, very easy to use, and makes it a little bit easier to sort of onboard somebody to OpenWhisk and getting them to use the image. So a couple of notes on the deployment and the droplet configuration. It's running on an Ubuntu 18.8 image. It is using the lean OpenWhisk deployment, and that allows me to actually run within 1 GB of RAM and on 1 CPU, and as you saw, the response isn't terrible. It's reasonable. The Apache CouchDB instance that's running within the deployment is persisted on the host file system, so actions stay around and survive reboots, and you can even migrate the droplet image, and your actions will be there. you get, with the droplet, the way I sort of configured it is there's a script in there that as we update the workbench, we can give you a new key and you can update the workbench and get new capabilities as we sort of expose them or release them more widely. And the way the images are pulled, I sort of provision the image only with Python and JavaScript because those I think are the most popular, but all the other images get pulled on demand as you run an action in that runtime. So if you tried, Rust in the future or Ballerina or something else, it might take a little bit longer initially to sort of pull the images from Docker Hub. There's a few enhancements to sort of do, like the playground is nice, but maybe if you're actually hosting this image, you don't want it to be exposed and allow others to run actions on this image. So you have to enable and disable it. And we're thinking about providing configuration parameter for that. Closing off some ports, firewalling internal containers. And I think what's most interesting and maybe relevant to what Tyson's talking about is adapting the configuration to the VM size. So with the droplets, you can configure droplet sizes from very small to very big, and you want potentially that deployment to scale with your configuration size. So we haven't done that. We've sort of optimized for the small droplet sizes, but it's an interesting area. If there's demand there and we see it, we might do some work there. So any comments there before I solicit some feedback for next volunteer?
That looks great.
Thanks. All right.
Very cool.
So I think the last order of action is soliciting a volunteer for next time. If there are courageous volunteers, I'll gladly accept them. This was really painless. This was my first one, actually. I don't know how I skated for so long without doing one. And it was very low effort in terms of organizing, I think. So it's not a scary thing to do. No volunteers. Oh.
So the next one is on the 20th, right? Yeah. I can do it.
All right, Dragosh. Thank you. All right.
My pleasure.
Right on time then. Thanks everyone for joining.
Thank you.
Thanks. Bye.